G'day. In this series of videos, we are doing some psychometric modeling. We've started from scratch, and what we're doing is we're building up a model of a psychometric function. The psychometric function that we are using is a Gaussian. It's a normal cumulative distribution function. And in the first couple of videos, we've started by sampling from uniform distribution, and then we created our Gaussian model, and we've plotted it out, and it all looks fine. And then what we did is we started to create some of the data structures for the actual experiment. Now, this is not a real life experiment. We're not getting anyone in to do any psychometric experiments, but what we're doing is we're modeling it using just the samples from the uniform distribution. So if you haven't seen the previous couple of videos, stop here, work your way back, and they're quite short videos. Work your way up until now, and you'll see how we got to where we are now. If you have seen those other videos, let's get cracking. Now, heads up, this is going to be quite a complicated video. We're going to be doing a lot of things, and I'm probably going to make mistakes along the way. So, bear with us. It's going to be a learning journey. I've done this before, so that's not an issue, but it's going to be a lot of things coming together all at once. Okay, so if we make a bit of mistakes, or takes us a little bit to get through it, then hey, look, it's going to be a learning experience. So we've done video 1, we've done video 2, we've done video 3. So now what we have to do is we have to actually do our experiment. Right, so let's have a look. Subject response, model PR, experiment, trials. Okay, so this is our workhorse function. This is the function that's going to do all of our experiments for us. And so what we've done first, let's just quickly recap. We've basically created our subject, and he or she has made 1,000 samples from a uniform distribution, and then we've got them in an array called subject response. Okay, and then the next thing we did is we then generated our cumulative distribution function. That's what we're going to basically try and recreate using our uniform distribution, using a method of constant stimuli. Okay, so that's here. So now we've returned the stimulus intensities and the model probabilities that correspond to each of those stimulus intensities. Okay, and then we've now got this experiment here where we've just started to create the data array. So what we've got, what we need to do is we're going to need to do a couple of things to our experiment array. We will need access to the subject responses. Okay, now these subject responses, remember, were what we generated all the way back here. Okay, so we will need to run that function now. So subject responses. Okay, what did I say? Sub responses equals sub response function. Okay, so let's do this first. Let's get the subject response array. Now remember, these are the probabilities between 0 and 1 that we generated from the uniform distribution. Okay, and then what we need to do after we've generated those subject responses, we will then need to pass them into our experiment function, because we'll need to look at each point. Hey, what did that subject respond on that particular trial? It will become clear in a little bit. And then what we need to do is we need to generate and return our model. Okay, so that's our model PR function that we created before. Now, we do need the information here now. So model probability, we don't just have that placeholder, we will need that. And then we'll need to, let's run our experiment. Okay, so when we run our experiment, we will need to now pass it the subject response probability, so sub responses. We will need to pass it the array of subject responses, because we'll need to go through those. And we will need to pass it the model probability. So model prob, and that's what we're generating here. Well, that's what we're returning here from this function here. Okay, so subject responses and model probability. Right, so we need to update that. And so we will need to now pass in here model prob here. Okay, so now this experiment has a lot of arguments that we need to pass to it, but hopefully we should have that all up and running. So if we run this program, it should return no errors And yeah, it seems to have worked, hopefully. Yep, it's worked. So we haven't got any obvious errors here. So now we're in the experiment. We've got access to all the threads that we've been drawing and creating in the previous sets of videos. So we've got the subject response array. So this is, we will eventually populate this with our correct or incorrect responses. Okay, responses. The other thing that I want to create here is I want to create a global counter. Now you'll see why this is important in a little bit, but we'll just create, say, global counter, and we'll just instantiate that, we'll just initialize this to 0. Now, what we want to do as well is we want to automate our method of constant stimuli. We don't want to have to type in, okay, now do stimulus at 0. Now do stimulus at 10. Now do stimulus at 20. Okay, we have the ability to just automatically do 0 and then 10 and then 20 and then 30. Okay, the way that we do that obviously is with loops. And so what we can do is we can say for I in range. Now this is not the most Pythonic way of doing it, but you'll see why we use an iterator now. This letter I, 0 from I in range 0 to the length of. Now we want to go over all of the different stimuli that are in this stim X. So it's going to be 0, 10, 20, 30, 40, 50, 60, 80, 90, 100. So there's going to go through 11 different stimuli, intensities. So stim X. For I in range stim X, so this is going to automate. Or it's going to cycle over each stim X value. Okay. Well, let's just print out stim X, okay, I. So what's this going to print out? This is going to print out the value, okay, that corresponds to the position in stim X. So remember, this I is going to initialize to 0, and 0 is within this range here, okay, so therefore that's true, and so it's going to run into this loop. But what we're doing is we're printing out the value located at index 0, because remember we're passing this letter I, and remember that's started at 0, okay? And then once it's finished this, it's then going to increment I by 1, so now I equals 1. 1 is in this range here, and so therefore we're going to print out whatever's in stim X, that array, at position 1 now, okay? So what we should expect to see is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 print out. Okay, and it's done it automatically, and so that's what we've seen here. If you're not familiar with loops, have a quick look. There's a lot of tutorials out there on how to loop over certain elements and arrays in Python and in other languages, programming languages as well. So you see, so here we've got an ability to now loop over each of those stimulus intensities that we want to essentially expose our subject to. Okay, so here we go. So we've now got access to each of those. But now what we want to do is we want to, when we are looking at stimulus intensity 0, okay, we then want to do 25 trials or 10 trials or 5 trials. We want to do a certain number of trials at just that intensity. Okay, and then once we've done those number of trials, we then want to move on to the next intensity. Okay, so then it'll be now intensity 10, and then we want to do a certain number of trials at that intensity. So here we need a loop inside a loop. This is called a nested loop. Okay, so this is automating over the stimulus intensities. Okay, and now we want to automate, okay, or loop over the number of trials. And so we'll go, so for n in range 0 to number of trials. Remember how we created this number of trials before? So now we can control how many trials we do at each stimulus intensity. Okay, what do we want to do? We'll just print trial number. So we'll just say something like current trial is, okay, we'll just go %d, and then we'll print this out as n. So remember, this n will start from 0, and it'll work its way up to the number of trials, okay, and then it will just cycle up. So what we'll do is we'll print here, print in this outer loop, we'll say current stimulus intensity is something. So we'll go percent d again, and what we'll do is we'll pass to that the location in the stim x array. Okay, that's what we did before. We just printed that out, but now we're just naming it something. And then what we're saying is current trial is for this particular current stimulus intensity. Okay, so we'll see what happens. How many stimuli have we got? So number of trials is 10. Let's just make that 1 so we don't have to go through 10 each time. It will just cycle through 1 at a time. We'll only do 1. So let's see what we get. We'll run this like this. We'll go down a bit now. So you can see here. So the current stimulus intensity was 0, and then the current trial is 0. Okay, great. Current stimulus intensity is 10. Current trial is 0. Current stimulus intensity is 20. Current trial is 0. So this has worked. So what we're doing is we're saying, okay, we're going to do this first stimulus intensity, and so we're running at 0. And then we're going to do a certain number of trials at 0 intensity. Okay, so that's great. But you see what's happening here is that this current trial value is always reverting back to n. And so we don't want it to do that, because what essentially the program has done is it's done one trial at intensity 0, okay, but then it's gone to intensity 10, okay, and so essentially it's not doing 0 trials again, it's actually doing the first trial, because Python starts counting from 0, okay, and then once it's gone on to the 20 stimulus intensity, it's actually already done 2 trials, and so now we should be on, 0, 1, 2, onto the second trial. And so you see what we're doing here is we're not actually correctly counting the current trial number. We've just started back at 0 again. And so what we need to do is not print out the current n for this inner loop. What we need to do, remember, is go back to our global counter and say, hey, look, this global counter is going to control what trial number we are currently on, okay, in our experiment. So we don't want n, we want global counter, okay? But once we've done that, we always have to remember, once we've done a trial, remember to increment the global counter. Okay, so global counter plus equals 1, that's going to increment it. And so this inner loop here, yeah, it can go back between, 0 and the number of trials for that particular stimulus intensity. So it's internally consistent, okay? But you see, by having this line of code here, we're always incrementing our global counter regardless of how many trials we do at each stimulus intensity, okay? And it's this global counter. Please excuse me, I've got my headphones is going across the desk here. But anyway, each time we're running a trial, we're going to increment our global counter. So this is important. So now the current trial is not going to reset to 0. It should increment by a 1 every single time we go up. So let's have a look here. So we've just run the program at 1544. Yep, brilliant. So current trial is 0, yes, but then we've gone up 1 stimulus intensity, and so current trial is 1. Ah, brilliant. And so now we're on stimulus 20, 2, stimulus 30, 3. Okay, great. This is really good. So now we've got a handle on where in the experiment our current trial is located. Okay, so if we do something like number of trials 10, what we should see now, okay, is for every stimulus intensity, okay, we should see 10 trials, okay? And then we should see an increment to the next stimulus intensity, and then we'll do 10 trials. And then increment to the next stimulus intensity, and then do 10 trials, okay? So we should see 10 trials occur, but we're incrementing the global counter. So the global counter is actually going to it's always incrementing. So the next block of 10 is going to start at 10 and end at 19 in this case. So you see we've done 10 trials here from 0 to 9 at stimulus intensity 0, okay? And then in stimulus intensity 10, we've already done 10 trials, and so we have to start counting between 10 and 19. And so we've got 10 trials here. And then we've incremented the stimulus intensity by 1, and then we're doing 10 trials. So, sorry, I just zoomed forward a bit, okay? So here, this is important. We are not just counting and then resetting the count back to 0, okay? We need some global control over our current stimulus trial. Sorry, just the current trial of our experiment. I'm spending a lot of time on this, I know, but I need you to be clear that we need some way of incrementing through all of our response arrays at some point. Okay, because we don't want to go back and reread any previous values from our subject response array, because then we're going to get wrong results, and that's not what we want. We want the correct super number one awesome good time results. Okay, so hopefully I've bored you to death over why we need a global counter. But this is good. This structure is essentially the start of what we need to do. Now, what we need to do is we're looping over stimulus intensities, good. We're looping over the number of trials, great. Well, firstly, what we should do is we should return or get the probability of the Gaussian model at this stimulus intensity. Okay, so what we should do is we should say current model probability equals. Okay, so we need to get access to that. Well, that's going to be the model prob. Remember, that's what we've generated before, and we're passing into this value now. So it's going to be model prob, okay, at the same position in its array as the stimulus X array. So that's going to be I, remember? So this I value here is giving us the location in both the stimulus intensity array, or the X array, as well as the model probability array, the Y array. Okay, so here we can say, okay, we'll print out something like, print at so we'll just say at intensity, okay, and we'll put the current intensity, so percent %d, okay, model probability is, and we'll go percent. Now remember, this was a rounded float value, so we'll need to say something like a percent, so like something like this, 3.3f will be fine. It's got, actually it was we rounded it to 4 decimal places, so this should be fine, percent. And then we want stim x at location I, and we want model prob also at position I. What we want to do is we want to say, okay, for stimulus intensity 0, we want to know what the model probability is that corresponds to that. And then at stimulus intensity 10, we want to know what the model probability that corresponds to stimulus intensity 10. Okay? And so let's just see if we've done that. So instead of doing 10 trials per stimulus, we'll just do one. So it will just save us a lot of space to see what comes out. So we'll run this program again. So here we go. We'll have a look here. Let's have a look. So 30, 20, 10, 0. So here we go. So the current stimulus intensity is 0, and we said at intensity 0, the model probability is 0. Well, that's correct, because we'll write down at the left-hand side of that model probability curve. And the current trial is 0. Okay, that's fine. So at stimulus intensity 10, okay, the model probability was 0.0002. Great. Okay, and then we've incremented the current trial. And then you can see we've now got access to the model probabilities that correspond to each of the stimulus intensities. So if we go all the way up to stimulus intensity 100, okay, at stimulus intensity 100, the model probability is 1, so it's again 100. So this is good. We've now got access, quick, cheap, and easy access to the stimulus intensity and the model probability that corresponds to the stimulus intensity. Okay, great. I'll just have to pause this video. I'll be back in a little bit. The boss is asking me to pick her up from work. Okay, so I'll see you in a little bit. Hang on. Okay, I'm back. So I'm not sure where I left off, but anyway, let's continue on. We've got access to the global counter, we've got access to the current model probability, and we've got access to the trial counter and the current stimulus intensity. So this is all really good. Let's now look into the subject response array. Remember, that's the uniform distribution array that we created right at the start. And let's pull out the response probability, okay, for each individual trial. We're not going to do it all at once, but we want the ability to say, okay, this is current trial 10, okay, and so we want to go to the 10th value in that response array, pull out that value, okay, because we need to look at this value and compare it to the model probability. So what we're going to do is we're going to do it actually inside the inner loop, because this is where we're going to be running each individual trial. And so we're going to say something like current current subject response probability, okay, equals. So what does it equal? Well, we need to go into the array that contains those. So it's going to be this array, subject responses. So sub responses. Oh, I don't know why I'm capitalizing today. Sub responses. Okay, and we want to go into that array, and we want to go a certain number of values into that, or indexes into that. And the index that we want is not the n for the number of trials, but rather it's the global counter. Okay. So we want global counter. So we want to go the global counter value number of arrays in from the start of the subject response array. And we'll say, okay, print at, okay, for trial number, okay, %d, subject response was, okay, and then this would be 3.4f, because remember that's going to be some value, and we've it's a decimal place. Okay, so we want %, and so the trial number is going to be global counter, and counter, and the subject response is going to be car sub response probability. Okay, so this should print out every single trial. So we don't want the current trial now because we've got that located in this print statement here. Okay, so we'll get rid of that. Oh, we'll actually put a comment in here. So get the current subject response probability. Okay, that's for this particular trial. Trial. And remember, that's based on the global counter. So we'll print this out. We'll see what we've got out of it. Run this up like this. Okay, global. I spelled it wrong. Where is it? Where are you? Counter. Okay, so let's have a look here. We'll go back to the start. So current stimulus intensity is 0, okay. And intensity 0, the model probability was 0, okay. And for trial number 0, the subject's response was 0.3271, okay. And then all we're doing is we're just incrementing into the next stimulus array because we're only doing one trial per stimulus, okay. What I might do is I might just print a new line here. So we're visually breaking it up so we can see what's happening at each trial. So there we have it there. So at stimulus 80, the model probability was 0.9998, and for trial number 8, the subject response was 0.6587. So for this particular time, we ran the program. Okay, we've generated 1,000 responses, and the the 8th position in. Okay, the subject responded 0.6587. Okay, so this is great. Right, so we're getting pretty close to having to make a decision. Was that subject correct, or on that trial was that subject incorrect? And so the way that we do that is we compare the response, so the subject's response probability against the model probability. Okay, we've got access to both of these now. So we say now, if the current subject response probability for this particular trial, okay, so if current sub response, response probability is less than or equal to the current model probability, okay, if this is true, okay, the subject was correct. They made a correct choice. And so therefore we'll say something like print correct, or not correct. Okay. And then if the current, so we'll say something like else if, so if the current subject response PR is greater than the current model prob, okay, because remember we're using a cumulative distribution function, which is like looking at sort of all the probabilities up to that point. And so if it's less than or equal to that, they got it correct. Whereas if they're sitting above that, then it's incorrect. They were incorrect. Then we'll say, okay, the subject was incorrect. And then we'll say print incorrect. Okay. And so what we should see now is for every single trial we're making this comparison, hey, was the response, the subject's response probability less than the model probability? If it was, hey, they got it correct. Less than or equal to, then they got it correct. Whereas if the subject's response probability was greater than the model probability, then they got it incorrect, okay? So let's have a look. Let's see what we've got. We're so close to finishing off this video. Okay, so then we say here, so this is the last one that we've run, 16, 10, 38. Yeah, that's about right. So at intensity of 0, the model was 0. Okay, that's fine. For trial number 0, the subject's response was 0.4770. Okay, and so the subject's response is 0.4770, whereas the model, when the stimulus intensity was 0, is actually 0. So they should not get it correct at all. And so therefore, since this value, the subject's response probability is greater than the model response probability, then that's incorrect. And so this is what we've done. We've said, okay, the subject was incorrect for this trial. And so if we now run up to, say, the other end of the curve, right up at, say, 100. So here we go. At stimulus intensity 100, the model says it should be 100. And at trial number 10, which corresponds to the stimulus intensity of 100, the subject had a response of 0.4014. 0.4014 is less than 1, and so therefore the subject got it correct. And so therefore we do have the correct order of correct and incorrect responses. Okay, it takes a little bit of a while to get your head around it, but the main point here, the way that we decide if the subject is correct or incorrect is we say, okay, if the response probability from the subject is less than or equal to the current model probability, the subject got that particular trial correct. If, however, the subject's response probability for that trial was greater than the model response probability, they got that trial incorrect. Okay, so we're almost there. Remember how in that last video we created all these empty arrays, okay? We created 11 empty arrays, and I said to you, hey, we're actually going to put into these arrays all the responses, whether or not the subject got it correct or incorrect. Well, we need to do that now. So how do we do that? Well, we've got the empty arrays here. So subject response array. Okay, so we want subject response array. So subject response array. Oh, capital letter again. Response array. But of all of these arrays, okay, remember it's an array of arrays. Okay, we're currently in the first container of this for the very first time we've run these. And so we need to index into the first array. So we basically say, okay, in this first array, okay, we want to now start adding in the trial data for that particular array. So what we'll do is we'll .append. Now the way that I do this is I say if the subject was correct, that equals the number 1. Okay. Whereas if the subject was incorrect, okay, so subject response, capital letter again, response array .I, so we're looking at the ith position in the total array of response array containers, we're going to append 0. Okay, and what I'm going to do right at the end, okay, is we're going to go back one more, is we're going to actually return the subject response array containers, because we're going to Command Z that we're going to eventually at the end of at the end of this video, actually in the next video, we're going to do all of our analysis to look at proportion corrects at each stimulus intensity. So we're going to actually just return the subject response arrays. And so because we're returning something, we need to put it into somewhere. So we'll say subject response, we'll just say experiment response array equals this. Okay. And so what we should see now is an array container, okay, where each individual subarray or internal array inside that should now start to contain the trial by trial information at 0 stimulus intensity, and then the next array across we should see the 10 stimulus intensity of 10 trial information, ones or zeros basically, and then we should be able to see this whole array, you know, start to manifest itself. Okay. And so, well, I haven't actually printed that out yet, so hang on, let me just print this out right at the end. So we'll print experiment response array. So the last thing that we should see when we run this video, when we run this program, is a bunch of arrays where the trial data for each response is in there. So, oh, that's what we can see here. So we've got our response arrays here. So we've got for stimulus equals 0, for stimulus equals 10, for stimulus equals 20, 30, 40, 50, 60, all the way up to 100. We can see that they got that trial incorrect, 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 incorrect. And then at a certain point, they started to get them correct, because remember, their response probabilities were less than or equal to the model probabilities, okay? And so you might ask yourself, well, why is there only one value in each of these arrays at each stimulus intensity? Well, that's because, remember, we've only asked it to do one trial at each array. So what we're going to do is we're going to print out here, so print, experiment arrays as follows, okay, from stim equals 0 to stim intensity equals 100, okay. That just reminds us what each array does, or what each array relates to, and we'll do, say, 10 trials in each. Okay, so because we've got them all as functions now, and it's all automated, we've got loops nested inside other loops, we don't have to do anything else apart from just change the number of trials. And so here we go. The experimental array was as follows. Okay, so when the subject did trials at 0 stimulus intensity, this is the first array that we're looking at here, and, well, they got it all wrong. Got every single trial wrong. And that's consistent with the fact that the model probability at 0 intensity, it was 0. So regardless of what that subject, was responding based on its uniform distribution, they were always higher than 0, which was the model response probability. Because they were higher than the model response probability, they were incorrect. Okay, and we can see at stimulus equals 10, they got them all 0. At stimulus equals 20, they got them all wrong. But at this stimulus intensity, hey, they started to get a couple right. And then they started to get a few more right. And then more right than wrong. And then they started to get them, this subject started to get them all right. Okay, so you can start to look at this data here and go, hey, this is starting to look like the underlying Gaussian curve, okay, that what we used to generate our model, or to generate, that our subject was modeled on, okay? In the next video, what we're going to do is we're going to start to calculate the probabilities or the proportions from all of these arrays. But all we've done now is we've just said, okay, we're going to automate the stimulus intensities. We're going to cycle through each stimulus intensity, and we're going to cycle through each trial, or for a certain number of trials, at each stimulus intensity, and we're going to increment a global counter, so it's going to count up, and then that's going to give us the position in each of the stimulus arrays. Okay, it's going to count up by 1. You can see that. This is me counting forward, and then at the end of the day, we're going to return this array of arrays which now contain the trial by trial information at each stimulus intensity. Now, like I said, this is quite a difficult video to get your head around. This is the nuts and bolts of running the model. We've done a lot of things, okay? We've done loops, nested loops, we've done counters, we've done iterating, we've done conditional statements, if and then statements, okay? But hopefully, if you read the code that we've written, and you understand what happens when we do a loop inside a loop, and what happens when we do something like square brackets inside an array, we're indexing into that array. And if you understand things like .append just means you're going to add the value here into the array. So append just means into this array here, into this subarray, because we're indexing into that array, we want to add in at this value here. We're going to add in the number 1. Okay? Or we're going to add in the number 0 to the end of the array. So the array is going to get longer and longer and longer, and whatever value, 1 or 0, is just going to be added into the end of that. Okay? And we're going to do that a certain number of times, and the number of times that we're doing it is dictated by this thing called the number of trials. Because we want our subject to do each stimulus intensity 10 times, 15 times, 100 times, however many times you want to do it. In our case, we've got that as a variable. We've set it to 10 for this particular example. All right, I've been waffling on again for way too long. I hope this made sense. If not, read through the code again. Go to other videos and see what happens when you do loops and nested loops and things like that, and then come back. And hopefully what we've done should begin to make sense. All right. In the next video, we're going to learn how to convert all of these trial by trial information, so all of these values here, 0s and 1s, into probabilities. And you'll see why we've used the number 0 and the number 1 in terms of calculating counts and probabilities. All right. Leave this video here. Best of luck, and I'll see you in the next video. All right. Bye-bye.